Welcome back to our series on mathematical statistics. I'm Mark Ledbetter. This is video number 37, lecture 18, part A, and we are starting the topic called hypothesis test. And we're going to start with the hypothesis test for the mean, the population mean, mu. So first we want to, in this video, go over the concept of hypothesis test. And to do that, we are going to keep this fairly basic, but I do want you to know that confidence intervals and hypothesis test are two sides of the same coin. They're both based on decision theory. And so you can use a confidence interval to perform a hypothesis test. So they both are aligned with each other. We didn't discuss one-sided confidence intervals. That is where you are only interested, let's say, in whether the maximum value of something, not the minimum, or you're only interested in the minimum value of something and not the maximum. Okay? So we could use these confidence intervals to perform hypothesis tests. Okay? But most undergraduate texts do not do that, and so we shall not. But I do want you to know that confidence intervals and hypothesis testing is based on something called decision theory. And decision theory has been around a long time, and it's very well respected. Okay? So hypothesis testing is very powerful when it is used properly. Okay? So, of course, people have found ways to abuse a concept, and this concept has been abused, and there are debates going on within the statistical community of how to address that abuse and prevent it from occurring. Okay? So, let's get started. So we have many practical situations that require us to make a decision. And as I mentioned, decision theory. Make a decision about the numerical values of one or more population parameters. And these are unknown population parameters. Okay? If we know their value, we do not need to do a hypothesis test about that parameter. Now, a hypothesis is a statement about, in this case, an unknown population parameter. Okay? And a hypothesis test is the procedure that we follow to decide which of two hypotheses are true. Okay? So there are 5 steps that you will be required to always provide for every single hypothesis test in this class. You want to do all 5 steps to get credit. If you leave something out, you will have points deducted, so please don't do that. Every part of this hypothesis test is important. So the hypothesis statement is the first portion. Then we're going to talk about the test statistic. Then we're going to give a critical region. It's also called a rejection region, or you could say that it's the rejection criteria. What do we need to reject the baseline or status quo or null hypothesis? And then the decision, whether we reject or fail to reject the baseline hypothesis statement. And then the conclusion. The conclusion is the portion that is least talked about in statistical courses, and it's the most important step because everything up here, statisticians understand, but most of the people that will be reading the results are going to be non-statisticians, and this is where you communicate with them in a way that they feel comfortable, that they understand what has happened and why you made the decision that you did. Okay, so let's start with the hypothesis statement. Now, there are, and this is for mu, the population mean. So this is the population mean. Okay. We never do a hypothesis about a test statistic or a statistic, we never do it about statistic. We know the value of a statistic. The statistic is the value we calculate from the sample that we've taken. There is no error in there except maybe measurement error. So we don't do a hypothesis test for that. We do that, a hypothesis test, for the population parameter that we don't know. So the baseline for this first section is called the null hypothesis, and I abbreviate hypothesis, HYP, and it always has an equal sign, always. Now, when you get to more advanced statistics, they may talk about a more practical sounding one where you used a sign that says, in this case, it would say less than or equal to. In this case, it would say great. In this case, second case, it would say greater than or equal to. But we're not going to address that because this is the standard way of writing this. And the reason that it's the standard way of writing it with the equal sign is that this is our baseline or status quo hypothesis, and we're going to use this null hypothesis to calculate probabilities. Okay? And then we have three possible cases for our claim. Or it's also called an alternative hypothesis. Okay? And so depending on what we want, the claim is what we want to show, usually what we want to show. I won't say prove. Prove implies that it's 100%, and nothing in statistics is 100%. Okay? So we have our null hypothesis, which is H naught. That's how you say that. That's a 0, but we call it naught, H naught. And then we have H1, which is our claim or alternative hypothesis. And this statement also includes something about our significance level or the level of the test. We call it alpha. And we will talk about this a little bit later in this video. Okay. So the parts of this hypothesis statement, as I've mentioned, H naught, we say this H naught, phonetic, H naught. The null hypothesis is a statement about an unknown population parameter which is used as the baseline for calculating probabilities. It is accepted as possibly. This is a very important word. So let me say, if you have Z, probability that Z is equal to any number, this probability is 0 because we have to have area, we have to have a range of values for a continuous distribution in order to have area or probability. So if I say, what's the probability that Z is equal to Z naught? Well, that probability is always 0. So whether we believe the null hypothesis or not is not up for debate. We never really believe that it's actually true. We just say that it could possibly be true, or you could say it's approximately true. In other words, mu is approximately equal to mu naught. It's close to that value. That you could say that. You could, but more accurately, it is to say that mu could be mu naught. Mu could be equal to that value mu naught, okay? So, and we're going to say that H naught, the null hypothesis, is possibly or approximately true unless we have some strong evidence to say that it's not, okay? And my abbreviation for otherwise, in case you don't know, is OW, or zero, OW, not 0. So this, again, is also called, the null hypothesis is also called the status quo hypothesis. And again, my abbreviation for hypothesis is HYP. Now, the second part of it, the second statement. So the null hypothesis is one statement. The alternative hypothesis, H1, is the other statement that's made, or other hypothesis in the statement. Okay? It's the hypothesis that the experimenter usually I will say that's not always, but usually expects or hopes to establish as true. And this is a very important part of it that's often left out at this level, but I think, or this stage in explanation, but I think it's important that you get used to it early. We want to establish this claim or alternative hypothesis, I'll write claim up here, at a predefined or predetermined probability, which is called the confidence level, and I'm going to use capital C for the confidence level in this course. I don't think our book does, but I will. This is also called the research hypothesis, okay? What we're researching or trying to prove. So the hypothesis statement needs to include a level of probability, usually stated as a significance level, which is alpha, okay? And in order to understand our confidence levels and significance levels, so I've mentioned confidence level C and significance level alpha, we need to define the types of error that we can make in our decision. And our decision is going to either be reject the null hypothesis, reject H naught, or we're going to fail to reject H naught. Now, some people will say accept H naught. The way it's written in here, I would never say accept H naught because that, again, is very misleading. We don't believe H naught is true. We say that it could be true. We would accept that it's true over the alternative, but not that we believe the null hypothesis is true. Okay? So we have the type 1 error, and that is the error where we reject H naught given, so this is conditional probability. So it's the error or probability. No, it's not the probability. This is the error. We're just talking about the error, not the probability. We're going to, if we reject H naught, given that H naught is really true, we've made an error. H naught is true, but we've still rejected H naught. So we've made an error, and this is called a type 1 error. Now, the type 2 error is where we fail to reject H naught when H1 is really true or H naught is not true, right? But we have to be careful here. This is the correct way to say it when H1 is true. When we talk about type 2 error, we are specifically talking about a certain H1, okay? So a certain alternative or claim, all right? So let's talk about the significance level. This is a probability. It's the probability of making a type 1 error, which I can then restate as a conditional probability. It's the probability of rejecting H naught given that H naught is true. This is a significance level, alpha. And this is what we predetermine this value. And a default is 0.05. Okay? Very well accepted for application. Beta is the probability of making a type 2 error, which rewriting it in conditional probability terms would be the probability that we fail to reject the null hypothesis when H1 is really true. So we should have rejected H naught, but we didn't. So we made an error. This is a type 2 error. Now, the confidence level is simply 1 minus alpha. This is important. So if we say that we want a alpha of 0.05, then C is going to be 1 minus 0.05 or 0.95 or 95% for our confidence level. And I can write this as failing to reject H naught when H naught is true. So this is not an error. This is correct. Correct decision made. Okay? And then we've got the power of the test. And the power is 1 minus beta, and that's the complement of the type 2 error. This was the complement of the significance level. This is a complement of the probability of making a type 2 error. So 1 minus beta is equal to the probability of rejecting H naught when H1 is true. So again, another correct decision here. So these two are the probabilities of making correct decisions under different situations. And it's important to note that C and 1 minus beta, so the confidence level and the power are correct decisions, and their values are dependent upon each other. So you can't set both of them at 99.9%. Their values are dependent, and this was supposed to be R, are dependent and depend on N, and beta, 1 minus beta depends on N. So we predetermine, or we set alpha, and then beta is just occurs, and it's based on our sample size. So to increase, or 1 minus beta, to increase the power, we have to increase our sample size. Okay. So again, I've summarized this. We set alpha, and beta is determined for each individual H1 by the sample size N. And what I mean by this is there are an infinite number of these H1s. Because if I say that H1 mu is greater than 18, then mu could be equal to 18.1, 18.2, 18.3. To determine beta, or 1 minus beta, we have to actually create an H1. That's the only way we can calculate the probability to calculate the power of the test. 1 minus beta is the power. Okay? And we will not get into that in this course. So again, to increase the power of a test at a set alpha, or significance level, we have to increase N. Okay? So we're not talking about sample size in this course. That is something that they give you some basics on in introductory statistics if you wanted to take that. If you haven't taken it, then of course you certainly could. But we're at this point, we're not going to talk about it. And so now we're going to, we talked about the different parts of a hypothesis test. So we've talked about now the hypothesis statement, and we're going to now talk about the test statistic. And so the test statistic, it's the statistic that in other words, it's calculating using the data from the sample. And this statistic, we're going to use it to decide between H0 and H1. And we need to specify the test statistic because, as you see, there's going to be several different test statistics we could choose from. Not all of them are correct to use. And if you took several more statistics courses, you'd find that there are different ways, methods that have been developed by different people on how to test for the mean, the hypothesis test for a mean. There's a lot of different methods that are out there. We're teaching the basic one. Okay? So the critical region is the set of values for the test statistic. And this set of values are, if our test statistic is in this set of values, then H0 will be rejected. Okay? This is also called the rejection region. Or I like to call it, and it's often called, the rejection criteria. And so I have a table that I want to show you. So I hope that you will write this down. This is for the critical value method, and that's what we're talking about when we talk about the test statistic and well, not always, but when we talk about the rejection criteria for the critical value method, this is what we're talking about. So we've got some different cases that we'll discuss. The rejection criteria is determined by the alternative hypothesis. H1 determines what our rejection criteria is, or criterion, or criteria are, I guess. So if we know sigma squared, then we're going to reject, and the alternative hypothesis, is mu is less than some value, mu naught. Mu naught is some value, okay, just some value of interest. And so if our claim is that mu, the true mean, is less than that value, then we'll only reject the null hypothesis in favor of this alternative hypothesis if the observed value of the test statistic is less than the negative of z sub alpha. Z sub alpha is the critical value and is always positive. Okay. And we may have called it z naught in the confidence interval. Okay, but this will be a little different because it's z sub alpha. And if we know sigma squared or sigma, and our claim H1 is that the mean is greater than some value that's given, then we'll reject the null that they're equal in favor of the claim when z observed is greater than z sub alpha. And then this corresponds to our confidence interval, or two-sided confidence interval. We'll reject the null hypothesis that mu1 is equal to mu naught in favor of this alternative that mu is different than mu naught when the absolute value of the test statistic is greater than z sub alpha over 2, not alpha. Here we had alpha. These are called one-tail or one-sided tests. And this is called a two-sided test. And we'll see why that is. So what we're doing is, if we want to know if our claim is that mu is greater than mu naught, some value, some number, then when we calculate our test statistic, our rejection criteria is going to be, this is going to be alpha. Okay? So this is extreme, away from the mean. Away from the mean is going to be further away from 0, so a bigger positive number. And this cutoff limit is called z sub alpha. And if z observed is greater than z sub alpha, we reject H naught. And the probability, so we're going to calculate this under this probability, we're going to calculate it under the assumption that H naught is true. And so this is the probability of rejecting H naught, given that H naught is true. So we want this significance level to be small. Like I said, maybe 0.05 or 0.01 or 0.005 or 0.02. We could come up with any small value. Alpha is never bigger than 0.1. I don't know of anyone that uses an alpha that's bigger than 0.1. Okay? So this is for the one-sided upper tail test. Upper tail test. For the lower tailed test, still a one-sided test, but this is the lower tailed test. This would be negative z sub alpha, and the probability here is alpha to the left. Further, again, more extreme or further away from 0. Okay? So if we're only interested that our test, H1, that mu is less than some value mu naught, then our rejection region is when z observed is less than negative z sub alpha. Okay? And so again, alpha is our probability of rejecting H naught when H naught is actually true. We're going to calculate this probability alpha, assuming that H naught is true, and H naught is mu is equal to mu naught. So when we're going, we need to actually use a value, set a value so that we can calculate the probability. Without an actual value here, we can't get a real probability. Okay? And the two-sided, I won't go over these other test statistics now, but we'll use them as we go through those cases. But I will talk about the two-tailed test or the two-sided test. And in this case, the claim is, let me erase some of this. The claim, oops, don't want to do that. The claim is that mu is very different or different than or not equal to mu naught, whatever value mu naught is. So we're interested in mu being very different from mu naught. We don't care if it's smaller. We don't care if it's greater. We just want it to be far away from this value mu naught. If we only care about how far away it is, then we just care if z observed is extreme. So now we want 1 minus alpha here, which is our level of C. Here we had 1 minus alpha was below z sub alpha. Here we had 1 minus alpha was above negative z sub alpha. Here we want 1 minus alpha in the middle, just like we did with the confidence interval. And so we have alpha over 2 in each of the tails. And so this will be negative z sub alpha over 2, and this will be positive z sub alpha over 2. And so the rejection criteria is when z naught is greater than z sub alpha over 2, or when z observed, when z observed is less than negative z sub alpha over 2. It can't be both. Z observed is either a positive number or a negative number. It can't be both positive and negative. Okay? So when the other way of testing this is that the absolute value of z observed is greater than z sub alpha over 2. That's the other criteria. So you just take the absolute value of z observed. If it's greater than z sub alpha over 2, then you reject the null. Okay? So that's the way to do it in one step. So that is how we determined these rejection regions or rejection criteria for the test. Again, it's dependent upon H1. The rejection criteria depends on the claim. Okay? It always depends on the claim, not the null. The null is always the same. It's the claim that can change. Okay. So that's the critical region. Now, something that might help you when you're first starting this is you need to come up with the critical region, the rejection region. You may want to verify that when you do not reject the null hypothesis, then so you could list out the acceptance region, which is all the values that are not in the critical region. Okay, so you don't have to do this. This is not required. But I wanted you to know about it as a technique so that you don't get mixed up whether or not you should reject the null. If you write the rejection region, then write the acceptance region where you don't reject it. And make sure they don't overlap because they cannot overlap. Okay, decision. We're going to make a decision based on the rejection, the critical region. We're going to plug in values. Let's say that our rejection region is z observed is less than negative z sub alpha. Then we need to plug in values. This is less than this, and is this statement true or not? So plug in the values here. And if this statement is true, then we're going to reject the null hypothesis. So if the test statistic, or TS, is in the critical region, then we reject the null. If the test statistic is not in the critical region, then we fail to reject the null. Those are the only two decisions we can make. And everything about the decision is about the null, not H1. Even though this decision, we're looking at the critical region, this is based on H1, but when we talk about our decision is whether or not we believe that H1 is true or we believe it's false. Okay? Or it could be true or we believe it's false. And then the conclusion statement, and I want you to write this down. This is the format. Use this format always. Okay? So there exists. We could leave it blank. Actually, maybe I should put this, the line under it. Sufficient evidence to support the claim. So here we're going to write H1 in words at a confidence level, blank % confidence level, so 1 minus alpha, or C. And then we need to say that the test was performed using a random sample of size n equals whatever it was. This tells or gives information about the power of the test. The bigger the sample size, the bigger the power. The smaller the sample size, the smaller the power. Okay? So this is the format you need to use. And this part is the hard part. Putting your claim into words that anyone can understand. And this conclusion statement, this communicates the results of the test, of the hypothesis test, to lay people, not statisticians, nor even subject matter experts. So a good conclusion statement communicates the results of this very technical statistical test to people who may not know anything about statistical tests. So doing this is probably the most important part. Of course, in order to get there, you have to not make a mistake, or else this is worthless too, right? If you can't do the calculations and can't make the right decision based on the results you get, then your conclusion statement is going to be wrong. So it's all important, but if you did steps 1 through 4 correctly, no one cares if they can't understand what it means. So number 5 is how you communicate that so that the people who matter understand what you've done and say, good job, right? Okay, so that's it for this video. If you have questions, come to virtual office hours. If you need help before virtual office hours, by all means, email me. But you need to email me a picture of the problem because I probably don't have it memorized, and a picture of your work so far, so that lets me know how you're approaching the problem and how best to help you. And if you email me a picture of the problem, then I'll be able to help you faster because I won't have to wait until I can look it up. All right. Please take care of yourself. Stay safe because we want to see you here next time.